This is Evan Jones from lawschooly.com. Today we're doing Preptest 9, Game 2, The Diplomat's Dinner. This is a grouping game, pretty simple in and out game, but I think it's the kind of game that would really chew up a beginner. So if you had a hard time with it, I wouldn't stress it. You will figure out how to do better at this type of game. But I mean, frankly, it's just kind of like scary at first. So go easy on yourself if you had trouble with it. We'll figure out how to do it right here. For the setup, we have a group of 7 people. I've written them out here: J, K, L, M, N, P, and Q. And they're going to be attending a dinner, or at least some of them are. And 4 will attend and 3 will not. Okay, so I've divided it up into the classic in and out setup here. This is following kind of the LSAT trainer strategy with the drop down. You can also do it, this way is very common too. So it's up to you. And then when you know how many spaces you're going to have, it's absolutely critical to make sure that you indicate that. So put those 4 spaces where you'll have people going to the dinner, and the 3 spaces where people who are out, not at the dinner, will be. Okay, so we only have 4 rules, but they're kind of tricky rules. This is a kind of a classical biconditional rule. Either J or K must be selected is our first one, but J and K cannot both be selected. By selected, we mean they're in. The sort of power score way to write that would be with a biconditional like this, J and K, meaning whenever you have J, you don't have K, doesn't matter which side you're on. Another way that you might see is J, then, J, then not K, and then have the arrow going back and forth. The contrapositive of that is K, then not J. I prefer to just work with this. That's something that's up to you. Make sure you have a strong knowledge of biconditional rules. These are a key feature of in and out games particularly. More importantly, for this game, when you have J and K in a biconditional relationship like this, you can visually represent this very easily by writing J, then K here, meaning either one of J or K is going to be here, and then J and K over here. One of them is going to be in the out group as well. And now we've got this exact same rule for N and P. One of them has to be selected and the other can't be selected at the same time. So do that same step over for N and P. This is pretty good because already we've got a lot of our game board filled out. There's not too much left. One thing you might want to note is that you have only these 4 variables are going to always be assigned right here. They're totally used up, so all you have remaining is L, M, and Q. Sometimes it might be good to write those off to the side as sort of your free variables, because these guys will be very important going into these remaining spots. Okay, and then we have a couple more rules. N cannot be selected unless L is selected. If you're not brushed up on how to write unless rules, you take whatever is after the unless and put it over here, okay, and then you take what's remaining and put it over here. We have a complete lesson on conditional logic that covers this in more detail. I'll link to it in the post here. So click on that if you don't get these unless rules. Okay, and then we have Q cannot be selected unless K is selected, which is the same exact thing. Got Q, then K. Okay, so that's our main game board. There's nothing else we can really do to link these rules together or anything. Question 8 is a classic acceptability question. Do these the same way every time, which is take your rules one at a time and check if they're violated anywhere. So we take our JK rule, and we see that that's violated in A, cross off A. Take your N and P rule. That's violated down in E. Okay, take your N and L rule. That's violated in C. Okay, and your Q and K rule is violated in B. So that leaves only D as the correct answer. Just a reminder that that's always how you want to attack these, taking rules one at a time. It's the fastest way. Question 9 is the sort of problem that if this is your first time encountering this type of problem, you might have a real difficult time with it. And this is part of why I said this is a game that could potentially chew up fresh noob test takers. So, if you're a noob, don't feel bad about it. You'll definitely get better. This is a complicated distributional question. But once you've seen these a couple times, it's really easy to do. So among the people selected to attend the retirement dinner, there must be, and then we've got some options here. Let me write them out. Now, what this question's asking you to do is engage in some fairly tricky distributional logic. And by distribution, I mean taking stock of how many variables you have left. Like I said when we were talking about the setup, you've got your JK and your JK here, and your NP and your NP here. Those 4 variables are all used up. So there's only 3 variables remaining for these 3 spots here. And what the question's testing is that no matter which of these 3 you use, you're always going to have to use 2 of them over on this side, right? So you could use L and M, and then Q would be here, or you could use Q and M, and then L would be over here, etc., etc. But it does mean that when you take any 2 of them, you could say of it that you have to use one or the other or not both. And if that doesn't come to you right away, pause for a while and kind of just fill in the combinations and look at it. So all you need to find is an answer choice that contains 2 of the variables from this free group here. And we get that with B, L, or M, or both. Just make sure you see that and be aware that these distributional questions exist. They're a pattern that once you recognize them, it's not going to be that tricky. So B is our correct answer there. 10. Which one of the following cannot both be selected to attend the retirement dinner? With this, I'm kind of looking at these rules, and I think as an experienced test taker, you'll have the intuition that this question is going to get answered by having one of these occur, which will then trigger a variable that runs afoul of these not both rules up here. So I'd be looking to have an answer choice that says Q, because then K would be in. Q triggers the existence of K in the game, and then J. So Q and J would be a great candidate. Another good one would be oh, well, you know what? I just looked, and that actually solves the question. So that may look like I'm sort of like tossing up a magic wand in the air, but if you're looking for 2 people who can't be in, where is that information going to come from? It's going to come from the rules. So just think about who can't be in together as a result of these conditional rules. And that is Q and J, because if you have Q, then you have K, and we know K and J can't be together. That's a no-no. All right, so our answer is B there. Circle it and move on. Tricky question, especially for early in the game, but I think once you've got these question 9 and 10 out of the way, you're actually most of the way there with this game. Okay, for question 11, if M's selected if M is selected not to be involved in the dinner party, if they're out, if they're on the outside, what does that mean? Who can attend? Who has to attend? So let's look at that. If M's not selected, this is where it was really important for me to be mentally thinking about these variables that are sort of our free group up here. If M's out, then L and and Q have to be in, right? And then we can follow our rules from there, and we know that K is here, which means J has to be over here. And then we don't really know what's going on with N and P. Don't make the mistake of thinking because you have L that you need N. That would be a mistaken reversal of this rule. So it's still possible to have N or P over here. And with this filled in this far, you know it's going to be fairly easy to answer the question, which people have to attend, who have to be on the inside. J and Q, no, in fact that can't be true. And then we get to question answer choice B, and then we've got K and L. Yeah, K and L have to be in if M is out. So that's our correct answer. Once you have this down, very easy solve. All right, for question 12, if P is not selected to attend, so P's over here, then N's over here, then exactly how many different groups of 4 are possible in the in group? All right, well, so if N's in, we know L's right here. And then we have J or K. J or K. We don't know what's going on with them. And then what's left for variables? We've only got Q and M. They're the only 2 remaining from this free variable group. So all you need to do is figure out how many combinations you can make filling in this last blank spot over here, and that'll answer the question for you. So mentally, you know, I think this is something you can do in your head. If not, just write out the possibilities. If you have Q, that limits your options, right? Because Q, then K, so there's only one possibility with Q. M, on the other hand, could go with J or K. That's an additional 2 possibilities for 3 total. If you don't see that, go through and just do the different possibilities out visually for yourself. All right, and then 3 gives us our answer, C, circle it, and move on. Okay, for 13, it's a question that's very difficult, as last questions in games almost always are. You could consider moving on if you felt that you'd used too much time on the game, just talking about section strategy. However, I think it's a question that's not too difficult to do as long as you do the intelligent thing and rely on your prior work. So we need to find two variables that if they're put in the in group, they fully determine what the acceptable group over there is. So 2, where if we know those 2 are in, we know exactly which 2 other ones have to be in. I'm not really like wasting time thinking about smart candidate answers. Let's look at this. J and L. Well, if we look at this work that we did over here, we've got J and L in, right? Well, we could still have Q or M here, like we said with those 2 different possibilities. So J and L certainly doesn't do the trick. Cross A off. K and M. This might take a little more work. You might want to do a quick hypothetical to represent this. Have K, J over here, M, and then you'll see that, you know, of these 2, M and N and P, well, you can have either one or the other, so it's no big deal. Have Q here, L here, and you can switch those out. And anytime that this group isn't totally fixed, we haven't answered the question yet, so that's out. And then get to C, L, and N. Again, not going to work because we already see that we've got this LN group with an alternate possibility here, so cross C out. This is kind of advanced level strategy as far as using your work goes. It's not always set the way you need it to be to eliminate problems, but you have to visualize, okay, does this help me eliminate it quickly? And yeah, here it does. Okay, so C's gone. D, L and Q. What about L and Q? I'd need to draw another hypothetical for that one. Oh no, I don't, because look, I've got L and Q in up here, and then I see that this N and P combination is okay. So that crosses off D. We're left with E as our correct answer. If you don't really have a lot of faith in your work, sometimes it's worth it just to draw a quick one to figure it out that does settle the issue. You've got Q, and that leaves J in. Sorry, that necessitates K being in, so J's out. And then you can't have N over here because then you'd need L and you'd have too many people in. So you need to have P, and then L goes over here. And then our last variable is N. So that settles the issue. If you have these two, you need to have K and P over here. All right, pretty tough game. Time-wise, I wouldn't be surprised if that was taking, even a little longer than the 8.5 minutes. Depends on your experience level. I think better test takers could knock that out a little shy of 8 minutes. And if you're not anywhere near that yet, don't worry, because this is, again, a kind of game that is really tough on beginners, not so hard on people who've seen these patterns before. All right, thanks.